Hi everybody. In this video we're going to talk about compounding interest. So basically we're building interest upon old interest. Just a quick example. Let's say I deposited some money into an account. Let's say $100, right? So I have this money in my account and they're going to find out at the end of the month how much interest have I earned. So let's say I earned 5%. So 5% of 100 is $5. Okay, great. So now how much do I have in my bank account? Well, they just add that $5 in, so now I have $105 in my bank account. Let's say I don't add any more in. Here comes the next month. So now I'm starting with $105 in my bank account, and now they're going to give me interest on that amount of money. So I'd have to figure out, what is 5% of 100? And $5, so I'm getting out my calculator. Let's see, 105 times 0.05 is $5.25. So see, I just made interest on the interest that they gave me. So they're paying me money just to keep that money in the bank, right? So now I'm at $110.25. So that's what compounding means, making interest on interest that they're already giving you. So on your note sheet, you have these three formulas, and they're just an example of three different ways in which you could compound interest. So the first one says compound annually, and annually means once a year. Compound monthly means once a month. And then, a weird one, compound continuously means that it's just continuously being compounded. So that there's no, you can't say it happens every minute or every second. It's actually happening even faster than that, which is kind of weird. That's almost impossible when you think about it. But actually, this formula has a new number, which I'm going to introduce to you. And right here, it's the number E. So I would write this down. And the number E is approximately 2.7. Think about the number pi, and I'm also going to try to see who's paying attention to the audio part of this video. So I'm not going to write it down, but I'm going to check and see if you write this down on your note sheet. Pi is approximately 3.14. So I'd like you to write in the bottom right-hand corner of your page right now the symbol pi. I want to see who's listening. That has nothing to do with these notes. I just am giving you a little sound check. Alright, so we have these three formulas, and we just need to figure out, well, which formula should we use? So in the first example, we have Janet, and she deposits $700 into an account that pays 8% interest, and it's compounded continuously. So, okay, let's see, which formula do I use? That would be the third one. I'm going to write that down. So this is the formula that I should be using. Alright, so it says, write an equation that gives the amount of money Janet has in her account at time t. So I'm going to fill in all of the pieces of the formula that were given to me. So y, let's start with y. Y represents the final amount after compounding interest has been calculated. Well, we don't know what that is, so I'm going to leave that as y. P stands for the principal, which is also the starting amount. Excellent. That was our 700. So I'll plug that in for P. Remember that E is a number. I'm actually going to put the number E. That's not a variable. R stands for the annual interest rate, written as a decimal. So what do I have to do with this 8%? I'm going to move that decimal over 2 places to the left. So now it's a 0.08. And I'm going to put that as an exponent. So I'm going to make sure to write that small and kind of elevated right there. And t is the time, which we don't know, so I'm going to leave that as t. Perfect. So we have our equation. We want to figure out, for B, how much money will Janet have in 5 years? Well, that's our time. Notice T stands for time in years. Perfect. We have 5 years here. We're going to plug that in for T. So y equals 700 times e to the 0.08 times 5. And that's all in that exponent right there. So I'm going to type that in my calculator right now. So I'm going to type in 700. The number e is right here. It says e to the x. If you see it right here, I'm going to hit second ln. And now notice it already gives me the caret, which is perfect because I'm going to be putting in the exponent 0.08 times 5. And enter, and there's our answer, $1,044.28. Perfect. Let's try the next example. Alright, so now we have Joyce, and she also deposited $700, but into an account that pays 8% interest, compounding annually. Everything has stayed the same except for the compounding annually. The annually is going to tell us which formula to use. And I believe that was the first formula. So I'm going to write that down here. That was y equals p times 1 plus r to the t. Okay. So let's fill in what we know. We know the principal, the starting amount is $700. The rate is 0.08 when we change that to a decimal. And we'll leave that to the t power. And there's the formula for compounding annually, filled in. How long will it take for Joyce to have $1,000 in her account? Notice this is a different question than the first one. This time, they're giving us the ending amount. That's what y stood for. So I'm going to substitute 1,000 in for the y. Might as well add the 1 and the 0.08 together, so I'll write that as 1.08 to the t power. Now, just as with the other videos in this chapter, we always used graphing to solve these equations whenever there was a variable in the exponent. That's the only way we know how to do these. So this is going in y1, this is going in y2. So here we go in y equals, y1 is 1,000, y2 is the 700 times 1.02, caret to get the exponent, oops, sorry, that should be a 0.8, caret to the x. And I want to see what this looks like. Ooh, notice that I can see it right away, but that's because my window, notice the y max was going up to 2,000. It had to go up to something beyond 1,000 if you wanted to see that line. And I can see my intersection. That's what I'm looking for, so I'm going to find that. And there it is. So we have an intersection at 4.634, comma 1,000. So let's use that to answer the question. How long will it take for Joyce to have $1,000 in her account? That's our x value right here. In a sentence, it will take Joyce about 4.634 years to have $1,000 in her account. Alright, notice that I haven't done an example using the second formula. It's just a formula. We're going to plug in everything else the same, and we're going to do the exact same steps. Good luck.